Good morning, family. It's good to see you. It is I, your intrepid instructor, Mr. Romer, and today is 6/19/2020. That is June 19th or Juneteenth, 2020. BLM. Glad to have you all with us. I miss each and every one of you. I want you to know that though atheist, I do have thoughts and I make requests of the universe that we go back to class soon so that I get to see all you guys. Sorry, I have a side fan and it messes with my hair. There you go. Ta-da! So yeah. Thumbs up to all of you for making it through so far. I'm proud of you. This is not easy. There's no other way to describe the fact that we are in the middle of a genuine pandemic, that we are doing our best within our nation to, as a people, to get through this double-headed issue. Not just the pandemic, but also the whole world waking up to the systemic movement against the subjugation of people of color, and a whole bunch of people like me getting woke and realizing that just acknowledging it isn't enough, to go on protests and stuff, to stand with brothers and sisters to make sure that everyone knows that we're with Black Lives Matter. I'm not making this political for those who might watch it. I'm simply stating, you guys know I have black kids, so it's important to me. So I'll make mention of it every time I make a video. Dr. Evil, I presume. So anyways, onward. I think today we're going to do ammeters. So let's get our erstwhile automotive Bible out. Oh, I see everybody. Hi, everybody. How you doing? How you doing? Ooh, I might use that Wendy Williams. How you doing? She's awesome. She's fun to watch. Here we go. Ammeter, a device used to measure current flow. So, in a nutshell, that's what it is. Ammeters in general, the new ones are digital. They come with circuit boards. They come with all kinds of chipsets in them. They have a lot of functionality. They can do everything from take temperature to measure RPMs to checking ampere flow. They can check voltage. They can check resistance. They can check anything to do electrically. And they're small. That's the other fun thing. For such an incredible piece of electrical equipment, they're getting to be Star Trek tricorder size. Like, beep, beep, beep. Here it is. This is, really small. Very, very small. And they're also getting to the point where they don't have separate channel inputs. So there's always the one common, also known as ground or return. That's usually the black wire called earth, common, ground, return. Back leg. I've heard them all called that. Hey, put the back leg on it. Make sure it's got the circuit complete. Okay. And you test for that. The other side's called the hot side, red, live, power, positive, plus. Oh, the other side's also negative, So all of that. When diagnosing cars, ammeters, excuse me, it's morning and I haven't had coffee, is one of the most amazing open, it's just an open source thing, which means there's directions on how to use them everywhere. And for a mechanic who really wants to be a technician, the ammeter is your best friend. It is a piece of equipment that each and every one of you should learn to use awesomely. So I'm going to type in on my search bar here on my phone, ammeter, and I'm going to come up with, and I want to show you on the thing, images of ammeters. And one of the more brilliant kind that you guys can see, and now even the cheap ones on like Wish, $11. I wouldn't buy it. That's made in China. It'll probably burn out the instant you show it more than oh, this is a good one. So the top of the industry is called Fluke, and that's not a fluke. This is an industrial multimeter. Good for 1,000 volts, right? Like a lot of amps. It has variable settings for voltage, millivolts, ohm for resistance, diode checks, milliamps, and amperes. Yep, safety rated Cat 3, 1,000 volts. Cat 4, 600 volt. And captures intermittence. Oh, it's able to sample once every 250 picoseconds. Here, let's see if you can see it. And 250 milliseconds, just super short windows of time. Includes built-in thermometer and temperature probe. Offers true RMS AC voltage and current for measuring non-linear signals. One of the awesome things that this can do, pulse width modulated motor drive signaling. Okay, I'm going to officially go off the deep end. No, I'm going to not do that. The next step up from something like that, a digital multimeter, is this. That is a desktop controller. Has and take a look at the price. Also by Fluke, $20,000. Gas pressure controller, and that's a little, yeah. We won't mark. That's a specialized unit for something special. Well, here's one. You guys are going to really like this. This one comes with a line clamp. So that's that round donut-y thing at the top and that gray button on the side. You push down the gray button, the thing opens up. And then you just go around a wire, and it can sense through the insulation everything from voltage and amperage going through the line. What if it's like a spark plug wire? It can measure how often or how intermittent the signal is. So cool, right? It is a way. Here's another one offered at Home Depot. Klein Tools. Here's a good one, $60, right? Look at that. $60, Home Depot. Ta-da! Oh, a friend of mine just commented. So these are all variations of a theme where you can measure, And in the automotive world, this is an ammeter. This one's for an aircraft. Measures 60 amps to negative 60 to positive 60 amperes, created by, and I will show you, FAA certified for an amp meter for aircraft, to see what the alternator generator is doing in an aircraft engine, whether there are problems or not. So I will also read to you. Ooh, check this out. Old-timey ammeter, one of the first ones, from Wikipedia. Ta-da! Right? I'll read it. A demonstration model of a moving iron ammeter. As the current passes through the coil, it increases. The plunger is drawn further into the coil, and the pointer deflects to the right off of its spring. It would look like this if you drew it out schematically, right? So basically, it's just a way of measuring, is a measuring instrument used to measure the current in the circuit. Electric currents are measured in amperes, hence the name. Okay. You can measure smaller currents known as milliamperes or microamperes. Are also designated as milliammeters or microammeters. They're interchangeable words. Potato. So, used in history all the way back. The relationship between electrical current, magnetic fields, and physical forces was first noted by Hans Christian Ørsted in 1820. I do believe Hans Christian Ørsted was Danish. Hold on. Yeah, Danish. Physicist and chemist. Chemist! Yeah, I need to talk about Ørsted's law. Here he is. Does he look confused about life? Like, who am I? Where am I here? We can go down this rabbit hole. This is what I do, looking for things for you guys. So using a multimeter, there are some certain basics that you need to know. One is, what are you measuring? Voltage or amperage or resistance? Those are the three key main ones. You will notice on most ammeters that there's a dial in the middle that clicks from location to location, click. And it usually goes DC voltage, direct current voltage, which is the first position, and it's delineated. The icon, the glyph, the drawing that represents DC current is a straight line with 3 dashes underneath it. That stands for direct current. The next one up is voltage, but alternating current, which is represented by a squiggle or a sine wave with a line over it. So you're measuring current, that's the line, and whether it's direct current or sine wave, those are the two different things. If you ask for AC current, you plug it on to a 9-volt battery, you get nothing. The computer inside the fluke inside of the ammeter will be like, I don't see anything. But if you go to direct current, it'll go, 9-volt battery. And it'll show you like 9.2 volts or whatever, fresh battery. The same thing is if you put direct current on and you stick it into the wall outlet, right, to check for current, the fluke's going to go 10 o'clock. The fluke's going to go, I don't know what you want here. I see a little signal, but there's no good signal, so I don't know what to do. Question mark. You turn it to voltage alternating current. It'll go, I see the current going up and below, pushing and pulling. Oh, Reed's is a 60 hertz, 120 volt system running 100 amps. House, just standard house current. Yay! Well, you won't see 100 volts, 120 volts and 100 amps at a normal outlet. You'll see 120 volts running 50 amps? No, 30 amps for a house electrical wiring for a sub panel, which means anything to do with lights, fans, air conditioning circuit, your hot water heater, the washer and dryer, those have 50 amp circuits. And the house has 100 amp circuit service breakers. So your house is designed to have 100 amps flow through it, of which those are all divvied up amongst all the things. And the main ones being your furnace, your fridge, your if you have a air conditioning system, like an internal AC, those will all have 50 amp buses, meaning fuse panels. Is it using 50 amps? Oh, no, not all the time. Most of the time, when you turn on the furnace or you turn on your air conditioning system, that initial spike to get the thing moving, that's when you're going to see like a 47, 48 amp spike. And then it levels off at like 20 amps. If it's running, if it's new and it's running, it just, it's like getting a car moving. You got to rev the motor, get the car moving. But once you got it moving, stick it in third gear and trundle along. Same with electrical equipment. The biggest charge point, the biggest electrical load is when an electrical item starts, because you've got to get that initial push. And an ammeter will show that. If you have the ones with the grabby donut on the top, you just, here, I'll show you, like, ooh, look at that. Take it right here, and you put the grabby thing around this, and it would, am I still recording? Good. And it would show whatever electrical this is carrying. And in this thing, it's only going to be 5 watts of power. So that's 120 volt, probably down to 12 or 10 volts DC, direct current. And then you'll only probably get around an amp, half an amp in this line, because it's LEDs. Sorry. Your light bulbs that you use that are normal ones, the incandescents, not LEDs, those run at 120 volt, and a bright 100 watter is going to be pulling like 9, 10 amps, I think. Maybe not that much, maybe 8. It adds up. You run a house full, you like 60 amps worth of light bulbs on, and it chews up electricity. That's a lot of juice flowing through the system. The system's rated at 120 volts. That's how big the hallway is. 40 volts, 50 volts, 60 volts, 70 volts. That dictates the width of the hallway that the electricity goes through. Amps is how fast and how hard those electrons are running through the hallway. You get a 9-volt system in microamps. It's a tiny little hallway, and they're walking. You got a 120 volt system running at 100 amps. Those are big hallways with big amounts of flow, lots of water. A lot of people do reference electricity. They say a good analogy is water. It's okay. It's good. Oh, so ammeters. Yeah. Did you yawn too? Even in videos. I watch videos of people yawning. Oh, you yawn too. All right. So you got the little switch. You set it to voltage, direct current. There's going to be a black wire and a red wire. Black wire is common, earth, ground. Plugs into the common. It's also color-coded at the bottom. It'll also be a black circle. And then you plug that wire in there. and then you have the red wire, and that goes into one of three locations on the bottom of it. One is for voltage, one is for amperage, one is for resistance. So you pick voltage because that's what you're measuring. So you put the red input onto the voltage line. So you've got it set for voltage, direct current, DC, and you got your 2 wires plugged into it. So then you go to a battery. Good old 9-volt battery, the square ones that you touch to your tongue and go, right? So you put that on your table, and you take your black wire and you go to the negative side, the negative terminal. And then, sorry, spam caller. You take your red wire and you go to the positive side. And then you go and you look over at your ammeter, and it'll give you a reading. Most new 9-volt batteries will come in at around 9.2 volts, between 9.2 and 9.6, depending on manufacturer, whether it's lithium, rechargeable, NiCad, which is nickel cadmium, whatever chemicals they use to make the battery. But most wet cell standard wrapped batteries that you buy from Duracell or Energizer are like lead acid types. So they just operate like the battery in your car. Same. Except no, the fluid is like a compressed wetness, not an actual liquid. Right? Friday, yo. It's Friday. I'll make a short video today, half hour. Ooh, we should talk about at the 22-minute mark, excuse me. 4, 3, 2, 1. Magic word of the day. What should be the magic word of the day? 22? Yes, 22 for 22 minutes at the magic. The magic word of the day was 22 because it was at the 22-minute mark. 22. So ammeters, yeah. You can set for resistance. So you might say, well, Mr. Omer, okay, so you check a battery. Is that it? Oh, no, there's so much more you can do. You can use an ammeter to troubleshoot an electrical fault in your car where a wire might be broken. Usually you can do that by checking for ohms or resistance. Infinite resistance means a line has been cut. If there's voltage, so here's another fun fact about flukes, right? You get a fluke, an ammeter. They have batteries in them. They have batteries in them so that if you need to test an electrical wire, you can test it. You can test it for resistance. You can test it if there's a break in it. Because believe me, you can take a thin electrical wire, pull until you hear it snap. Like you can break little thin, hair thin electrical copper inside of the insulation. So the insulation looks clean, but the wire inside has an air gap. So what you do is to show how to use the resistance value to see how much resistance is in a particular wire or circuit or in a motor, little electrical solenoid, or anything like that. You click this until it goes to what looks like a horseshoe. That horseshoe is called an omega. It is the last symbol, and it stands for resistance. Ohms. Ohm. Is it omega? Yeah, it's omega. My brain had a fart for a minute. I had to remember my electrical stuff. Let's look it up together. Electrical. I'm just typing it into my search bar. Electrical ohm symbol. So ohm. Go to Wikipedia. The ohm symbol. Yeah. I don't know if you can see it. There. The ohm symbol. See the little guy right there? Symbol. And it shows a little horseshoe. Ta-da! I got it right. And it's the amount of resistance in a circuit. So, how do you check a wire? Oh, wow, 30 on of the day. So you have a wire, and you take your multimeter, and you put one wire over here, the black here. Now the red wire, you have to select onto the ohms because it needs to take advantage of the internal battery, and you move it from voltage past amperage and over to the resistance or the ohm, the horseshoe symbol. And then you take the wire and you you take your probe. I call them wires, but I mean probe. Probes are wires with little metal, like stiff paper clips on the end. So this wire will come all wavy. But the end will have a little plastic handle and a metal paperclip thingy sticking out the end. And that part's called a probe. So you put the negative or common probe on one side of the wire. Then you take your red probe and you put it on this side of a wire that you've selected, right? Now you're measuring how much resistance, because it'll flow from the internal battery of the fluke. It'll measure electrical flow through the wire. It's not measuring for amperage or voltage. It's measuring if I push 1 volt through this side, I should get 1 volt out. No resistance. It's a clean wire. As a matter of fact, it's a perfect superconductor. Let's say you push 1 volt in and you get 0.9 volts out. A loss of 1/10 of a volt or 10% loss. So it's 90% electrically conductive. Pretty good. Let's say there's a lot of that greenish white powdery buildup, electrolysis buildup along the copper wire, hindering the flow of electricity inside of the wire. Then you hook up your common ground probe and your positive probe onto the wire, and it reads, I'm trying to push 1 volt through, but only 0.5 volts come out. I have a 50% loss. It'll show 50%, 0.50. Oh, wow, there's a lot of resistance in this line. I'm trying to push a volt through and only half of it's coming through. You can add as much voltage as you want. It won't change. It'll always be half. That's the resistance. The only thing that starts to happen is the resistance starts to heat up and that wire will melt. So if you have a bad wire, you try to flow enough voltage and amperage through it, you'll melt the wire. You'll actually cause the copper to liquefy, burning the synthetic covering of rubber or plastic or whatever compound of polymer you have covering the wire. That melts, and all of a sudden you have flames. And then the copper melts out, and you end up with a break. An open circuit, not a closed, where the electricity is a closed loop, an open in the loop. So when we talk about a closed circuit or an open circuit, just think about a loop, whether it's a closed loop or open loop. Closed loop, open loop. When we take the wire and we snap it, but we leave it inside the insulation, the copper wire now has an air gap. Electricity doesn't want to jump that air gap without sufficient amounts of voltage and amperage. But we're not testing air gap. We're just testing resistance. So we take the common and we put it to one side of the broken wire. We take the red lead, the red side, the plus side of the probe. We put it on the wire, and then it sends 1 volt through, but it stops because there's an air gap. Electrons can't hop the gap. Hap the gap. Hap the gap. That's funny to me. Hop the gap. They can't push through the gap because air is a natural insulator. You wouldn't think it because of lightning bolts, but lightning bolts fly through the air. And they said, yeah, because they carry millions of volts and tens of thousands of amps, just ludicrous amounts of electricity. One lightning strike can power a small town for 2 days, 3 days, whatever the new analogy is. They say if we could harness all of the lightning strikes on the planet Earth in 1 day, we can power New York City for a year. Amazing the amount of electrical energy comes back to the Earth from the friction of molecules in the sky. It's amazing. A lot of potential voltage up there. A lot of energy. So, because the voltage can't get through the wire, the computer goes, well, we're trying to send a volt through. Nothing's coming out the other side. So we have infinite resistance. 0.0, no voltage. That resistance is infinite. It's not 0.0001%. It's not 0.000000001%. It is 0. It's an infinite number. You can take the zeros and go on to an infinity. That's how much electricity is getting through. Nada. And we call that an open circuit or infinite resistance. Its ability to resist electrical flow is infinite at the 1 volt level. Obviously, if you want it to flow 120 volts and 50 amps through that wire, for 1 microsecond, electricity would hop the gap just like a spark plug. It would hop the gap and get across, completing a circuit. But here comes the rub. With a tiny little wire like that, trying to handle that 120 volt flow at 50 amps. Oh. All that electrical power, trying to go through an little wire. You're asking a wire that's used to handle cell phone signals, milliamps, tiny millivolts, to handle something that powers your washing machine. That thing turns into a fuse. It it burns instantly. It doesn't even flame. It just goes. It atomizes into ash instantly, and you end up with 2 nubs, which is actually the basis of fusing. Fusing is a contained weak spot in a plastic sandwich that you can physically look through and look at the wire, and the wire's been flattened and thinned out to a point that will only allow a specific amount of electricity and no more through it. And you'll have 5 amp fuses, 10 amp fuses, 15 amp fuses, all based on the automotive 12 volt system. So interesting thing about fuses will break if you exceed both the amperes listed or their class of family. So you have the 12 volt family, you've got the 50 volt and 60 volt families, you got the 120 volt families. You have different families of fuses. If within the family, you have different amp levels. You can definitely get a 120 volt 5 amp fuse. Absolutely. And you can get a 12 volt 100 amp fuse. Absolutely. The 12 volt 100 amp fuses Those are the fuses you find on high-end stereo systems. Those big copper cables, big chunky bus fuses, 100 amp. They're only 12 volt, but they can handle a lot of amps. Same for the house ones. You can get 120 volt family of fuses as little as 5 amps. Something that would run this LED light by my computer. Fuse that line. You can have them. It's easy. Your Christmas tree lights, 120 volt, 3 amp. 3. Usually it's located in the plug that you plug into the wall. There's that little plastic door on the plug, right? The plug's like this. You scratch at the base of the plug, and that little door opens up, and there's an itty bitty little fuse in there. 3 amp fuse. So if your cat decides to chew on the electrical wires of your Christmas tree, it gets a little zap, right? 3 amps, 120 volts. You'll hear it, and the cat will go and run, poop and pee everywhere on its way. But you won't burn the house down because the fuse goes off and all the lights turn off and electricity no longer flows through those wires for those Christmas tree lights. And you can find the fault if you have an ammeter. Yay. So, what do you think, team? Oh, 4th yawn. I'm exhausted. It's Friday. You know what? We're at 36 minutes and 49, 50, 36, 52, 53. I think it's good. We're going to go off. You ready? In 3, 2, 1. Fist bump.